welcome to my video. Before you want to watch my video, let me introduce myself. My name is Luhde Kusumasari. You can call me by Luhde. So enjoy my video and let's check this out. So after I tell you about the relation, now I want to tell you about introduction, sequence, and series. So what does a sequence and a series mean? Yeah, a sequence is a list of items or objects which have been arranged in a sequential way, like this. A sub 1, A sub 2, A sub 3, dots. Well, a sequence is basically a list, and you can see that the terms are separated by a comma. Yeah, separated by a comma. Like this. Okay, that's about a sequence. Now, what a series means? Okay, a series, can be highly generalized as the sum of all the terms in a sequence. For example, is like this: A sub 1 plus A sub 2 plus A sub 3 plus dots. A series is actually a sum where you're adding the terms together like this. So, after we know about what does a sequence and a series mean, now I want to tell you about any types of sequence and series. So, because from a sequence can make a series, some of the most common examples of sequences are: first is arithmetic sequences, a sequence in which every term is created by adding or subtracting a definite number to the preceding number is an arithmetic sequences. For example, just like this: 3, 6, 9, 12, and etc. These sequences are called by arithmetic sequences. Next, there are geometric sequences, a sequence in which every term is obtained by multiplying or dividing a definite number with preceding number is known as a geometric sequence. For example, just like this: 3, 6, 12, 24, etc. And then harmonic sequences. A series of numbers is said to be in harmonic sequence if the reciprocals of all the elements of the sequence form an arithmetic sequences. And the last one is Fibonacci numbers. Fibonacci numbers form an interesting sequence of numbers in which each element is obtained by adding two preceding elements, and the sequence starts with 0 and 1. Then, let's look at this first sequence here. we've got 1, we've got 3, 5, 7, 9, dots. This goes on forever and ever. But we want to talk about first is a little bit about the terminology. So this term here we call and equals 1. Okay, for the first term, and then this one here is and equals 2 and equals 3, etc. But the value of the term we refer to that number 1, this as a sub 1. Number 3 is a sub 2. Number 5 is a sub 3, etc. So that's a little bit about the notation. Now, let's say we want to find a set of terms in a sequence, and let's just maybe find the first 4 terms. Well, we are given here as we are given a rule or a formula in order for us to find those terms. So here we have a sub 1, Okay, that means n equals 1. That's the first terms. So what we are gonna do is wherever we see and we are gonna put 1 in place of n, and then we are gonna multiply by 2 and subtract 2. So 2 times 1 is 2 minus 2 equals to 0. You can do same formula or method from this for this tree. Now, I want to show you is say we go ahead and plot these points like this. First is 1, 0, and B is 2, 2, and C is 3, 4, and D is in this. Okay, you can see it's continuing at that same constant rate, and what you can notice here is this really looks like the equation of a line. It looks like y equals to mx plus c. It's like our slope. Let's look at another example. So, this one here, we have got a sub n equals 2 to the n power minus 2. How do we find the first 4 terms in this sequence? Well, we are gonna follow that same pattern we did in the last problem. We take a sub 1. Remember, n equals 1, that just tells us this is the value of the first term. But wherever we see n, we are gonna put 1. So that's gonna be 2 to the first power minus 2. Of course, 2 to the first is 2. Minus 2 equals to 0. And then you can do same pattern of this to this tree. Let's go ahead and plot this point. Now, I want to show you the pattern here. When This plot A or A plot is represent 1, 0, B represent 2, 2, C represent 3, 6, and D represent 4, 13. You will notice on this one. See how that variable is in the exponent position, or this is an exponential function, so you can see it's growing faster and faster like that. Okay, now let us find out how a sequence can be differentiated with series. First, sequence. Sequence is a set of elements that follow a pattern. But series is a sum of elements of the sequence. Second, in sequence, order of elements is important, but in series, order of elements is not so important. Third, in sequence, finite sequence 1, 2, 3, 4, 5 use comma, but in series use plus, like 1 plus 2 plus 3 plus 4 plus 5. The last one is infinite sequence, is 1, 2, 3, 4 dot dot dots, but in series 1 plus 2 plus 3 plus 4 plus dot dot dots. That's all about sequence and series. Thank you for watching. Don't forget to like, comment, and subscribe. Goodbye. See you in my another video.